Okay, 3a is just an equation. It's got an equal sign. It's got stuff on both sides. It's an equation. Just got to solve the equation. I want you to give this one a shot. On your scratch paper, right now. This is Precalc. This is the big time. Some kids say harder than calc. And we got to depend on algebra. You got to be good at algebra or you can't do Precalc. Another statement from a calc teacher. It's not the calculus that'll get you, it's the algebra. You'll hear that if you would go on to calculus. It's the algebra that really messes people up if they're not good at solving equations and being careful. It's not that calculus concepts are super hard. It's the algebra behind them. All right, so what I hope you did was 3x minus 3. So many people forget to distribute the 3 over there. Plus x equals negative x plus 7. And then these can go together and be 4x minus 3 equals negative x plus 7. And some people get stuck when there's variables on both sides. Hopefully not you. You should know that you've got to get rid of one of the variables. And which one do you pick to get rid of? Get rid of the smaller one. It works better if you get rid of the smaller one. That's smaller. So I'm going to get rid of it. I'm going to add x to both sides. Could you do it the other way? Yes, but it's smarter to do it this way. Because now I'll have 4x plus x is 5x minus 3 equals 7. And notice the variable is not negative. If you get rid of the smaller one, your variable won't be negative, and that'll work a lot better. Now I'm going to add 3 to both sides. 5x equals 10, and therefore x equals 2. Raise your hand if you had that one right. Okay, good. All right, this next one, it's just solving equations, just happens to have some fractions in it, which makes it scary to some of you, but you need to get over that because fractions are something we use a lot. All right. Okay. My smartboard's freaking out and it thinks the eraser is a marker. All right. Okay, this one. 1/4 n. How do I write that? I could write it 1/4 n, or I could write it n over 4. Do you get that that's the same exact thing as 1/4 n? Because that n could be thought of as n over 1, and then when you multiply the tops, you have n. You multiply the bottoms, you have 4, therefore it's n over 4. Now I go 1/4 times the 8. 1/4 of 8 is 2. If you wanted to do that out more, it would be 1/4 times 8 over 1, and then it's 8 over 4, and 8 over 4 reduces to 2. Minus 2 equals 1/2 n, I'm going to say n over 2, minus 3. All right, now do you get the plus 2 and the minus 2 will just disappear? And I'll have n over 4 equals n over 2 minus 3. Now I know a good calc teacher, Mrs. Hersman, her favorite way of doing these is to, I'm just going to move this off to the side, is to clear the fractions so that there aren't any fractions anymore. How can I get it so that if I multiply by just one number, that there won't be any fractions in this anymore? Multiply by something, not n. If you multiply everything by 4, now why is that going to work so good? Because 4 will cancel the 4. And 4 divided by 2 is 2. See how that works. And negative 3 times 4 is negative 12. And now I got rid of my fraction problem. I'm going to show you that again in a minute because that's a really powerful way of getting rid of fractions. It's called clearing the fraction. Because isn't this a lot nicer now? That it's just n equals 2n minus 12? A lot easier. Now I'm going to get rid of the smaller one, minus n, minus n. And this bothers people sometimes because they're like, well, everything's going to disappear. That's just n minus n, and that's 0. And then the final answer, add 12 to both sides, 12 equals 4. I like to write it n equals 4. Oops. All right, I just showed you a really, really powerful tip there, and I want to show it to you again. in a different problem. So say I had 1/3 n plus 6 is equal to 12. How can I clear that fraction so I don't have fraction issues anymore? Times everything by what? 3. Because as soon as I do that, times 3 here, times 3 here, got in the wrong spot, times 3 there. Now this 1/3 times 3 gets rid of that fraction. It's just n. Plus 6 and 3 is 18, equals 12 times 3 is 36. And now I just have to subtract 18. I got rid of my fractions. How did I do it? I look for the denominator and I get rid of it by multiplying by it. I'll show you one more time. Let's say it was 2/3 n plus 4/6, which is the same as 2/3. That's kind of dumb. Let's say 1/6 n is equal to 10. Now on this one, if I times by 3, it'll fix one of my fractions, but it'd be smarter to times by 6, because that'll fix both of them. See, if I times this one times 6, and this one times 6, and this one times 6, 2/3 times 6, I can put this over 1, and I'll have 12 over 3, and 12 over 3 will reduce to 4. Plus 6 times 1/6 is 1, so it's just 10 is equal to 60. And notice, no more fractions. So much easier now. Yes, ma'am. Why wouldn't 3 work? Let me show you. Let me go back and just do 3 and show you what happens. Times everything by 3. It will fix this first fraction, but it won't fix the second fraction. See this one? This cancels this, and I get 2n, plus this one is 3 times 1/6, which would be 3/6, also known as 1/2. And see, I fixed one of my fractions, but I didn't fix the other. Okay? And it could still do it. Now I just have to go multiply everything by 6. Okay, so let's look at some more stuff. This is called a literal equation. And you know, when you first started solving equations, they were baby equations like y equals, or 2y equals 8, and so therefore y equals 4, right? They're really simple. And then they got harder, and then they got harder. And now, pretty soon your equations had 2 variables, like y equals 2x plus 7. And they might say, solve this one for y. Well, it already is solved for y. They might say, solve it for x. There's only 2 variables. It's either one or the other. If I solve this for x, I go like this. It needs to be y minus 7 equals 2x, and then I divide by 2 to get x alone. Divide everything by 2. Okay, so the final answer would be x equals y over 2, or 1/2 y minus 7 over 2. All right. That was where there was 2 variables, but what if there's 5 variables? Or, let's go back to that e equals mc squared thing. If I give you this, I should be able to say solve for anything in there, and you should be able to solve it. What is it solved for right now? E. But if I asked you to solve for m, all you'd have to do is say, get the m alone. And so you'd go divide by c squared. Divide by c squared. M is alone. It's solved for m now. Could I solve it for c? Yes, but it's a little harder. How do I get the c alone? Well, first thing to do is get rid of what? The m. I'm going to divide by m. E over m equals c squared. And I'm really close. How do I finish? Square root both sides. Square root, square root. And now c equals square root of e over m. There is one technicality. Does anybody remember from higher algebra that the square root of c squared isn't really c? All right, it's absolute value of c. All right, now I know that's a tricky one, but I'm going, and we got to absorb a lot of information at once, but this one I'm going to stop and talk about for a minute, because I guarantee you will see this. I know the tests. I think you're going to see this same situation come up 4 times for this next semester on tests, usually on our 3 questions, which are the ones you need to get A's. So this is one of those things that separates pre-calc from higher algebra. Is you got to know some of the little details, some of the little technicalities. When you take the square root of 2 times 1/2, of a variable, your answer is an absolute value. I'm going to go back to a simple one that you'll all understand. X squared equals 16. Do you get that the answer could be 4? What also could it be? Negative 4. Okay. Now, watch what happens when I take square root and square root. If I don't know the thing I just told you, I'm going to go, oh, x equals 4. And you see how you'll get it wrong? Because what was the answer? 4 and negative 4, and you're going to forget that. If you remember that the square root of x squared is really absolute value of x, then you'll know you're not done with the question yet. You get what I'm saying? Now I got to finish this, and how do I get absolute values up? By saying that both, what are two things I could stick in there? X could be 4, and x could be negative 4. All right, telling you, 4 times next semester. It's not the only point to the problem either. It's a big, long problem, and at the end, somewhere in the end of the problem, you're doing the square root, and you're going to forget. Some of you will. You can't just do a square root of x squared and say it's x. So let me do one more time and see if you get what I'm saying. 2x squared is equal to 162. Say you were doing this. What would your next step be? Divide by 2. X squared equals 81. Yay, I'm done. X equals 9. What did I just do wrong? I forgot that whole square root of this is really absolute value of x. And therefore I have 2 answers. Okay? That's Precalc level. That's not simple stuff. Now you did learn this last year, at least some people. And some of you didn't remember it, but this was a crucial thing. And maybe you never were taught this. I'm convinced some people still aren't showing people this. But it's important to understand in Precalc. All right. Let's move on. Linear inequalities. Inequalities. What are those? Well, that basically means it's just like a normal equation, except it doesn't have an equals. It has one of those. Now, I don't want to start with a really nasty one like that. I'd rather start with a simple one. Let's say it was just 2x is greater than 10. Do you get that it's a lot like an equation, and I can just go divide by 2? And x is greater than 5. That's all you have to do. Solve them just like you solve an equation. But there's 2 times that they're different. One is, if you ever are dividing by a negative, do you remember what happens? Switch the sign. Very good. So if this had been negative 2x equals or is greater than 10, then you divide by negative 2. As soon as you divide by a negative, your answer still works and everything. It's just you got to switch that the other way. Okay? If you ever multiply or divide by a negative, either one. Not if there's a negative in the problem. It's if you are actually dividing by that negative. You know what I'm saying? Just because it has a negative in it doesn't make it automatically mean, you know. Some kids think, oh, it's got a negative in it, so I got to switch the sign. No, you're going to be adding 4 to both sides. You're not multiplying or dividing by a negative. I don't switch the sign in this one. Okay? All right. So now back to the ugly, hairy, nasty one. That one. Well, it's just got a few extra little tweaks that make it Precalc instead of higher algebra. I got to be careful with this, distributing this negative to both parts. And this has to get distributed. And then when I'm solving it, if I ever multiply or divide by a negative when I'm solving it, then I got to switch that sign around. Okay. And when you're all done, your answers usually look like this. X is greater than or equal to 5. And that means 5 would work, or 6, or 7, or 8. All right. I think, yeah, that's it. So today, you didn't have to learn near as much. We have a worksheet. I want to give it to you, and I want to work on a few of them with you, because I feel like once you get started, you'll feel a lot better about it. So, actually, I'll keep the video running for a minute while I do the first couple problems off this worksheet with you. So, would you, how about this? Would you hand these out? Thank you. Number 1 on your worksheet says 4x, you'll get your worksheet in just a second, plus, so she gives us a chance to hand it to you, equals 18 minus x. Whenever you're solving a big, long equation like this, your first step is just to multiply it all the way out. Once you got it multiplied all the way out, you put common like terms together. So this goes times by that, and that times by that. And I will have 4x plus 3x. And 3 times negative 2 makes negative 6. A lot of people forget that part. Equals 18 minus x. It's fine with me if you just write that down for number 1. And then you're partway there. 4x plus 3x. In fact, if you want to just put them right together and say 7x minus 6 equals 18 minus x, that'd be fine with me. Now, here's an important moment. You've got variables on both sides. A lot of kids get stuck. Which one did I say to get rid of? Smaller one. So we're going to get rid of the minus x. We're going to add x to both sides. And now I'll have 8x minus 6 equals 18. And now from here, if you can't solve this, run away fast. Because this is like the baby stuff now. Add 6 to both sides, divide by 8. Okay? All right. Remember me talking about that method for clearing fractions? Let's do that on number 4. It's x, number 4 is x plus 3 over 5 plus x over 3 equals 7. And the ones I gave you as an example in class were kind of easy ones where you'd either multiply by 5 or multiply by 3. But you know what? If I multiply by 5, it'll fix part of it, but it won't fix the whole thing. If I multiply by 3, it'll fix part of it, but it won't fix the whole thing. Who's smart enough to know what I should multiply by? 15, very good. I multiply by 15 here, and here, and here. And now let's write down what you would write down on your worksheet underneath the problem. Would be the 15 cancels with the 5 and becomes a 3. And if you just put 3x plus 3, you missed out because you really have to multiply the 3 times both parts. You get what I'm saying? This 15 and this 5 do reduce down to a 3, but it's not just on the x, it's a 3 times both parts. Plus 15 divided by 3 is 5x equals 15 times 7, I'll help you with that one. 10 times 7 is 70. 5 times 7 is 35. 70 and 35 adds up to 105. You could grab your calculator anyway if you wanted to multiply 15 times 7. All right, from here, again, this is the part a lot of kids would have goofed, is they would have forgot to distribute this 3 to both parts. 3x plus 9 plus 5x equals 105. And then I combine like terms, the 3x and the 5x make 8x plus 9 equals 105. And from there, again, you should be able to handle it, no problem. Did I make a mistake? Okay. I can do it in a different order. But multiplying by 15 fixed both denominators. Because when I do the 15 and the 5, they'll cancel, right? Because they both have 5 in common. And the 15 and the 3 will cancel because they both have a 3 in common. Should I explain that part again? Okay. So I'm going to back. You sure? All right. How about this? Tell me on number 3, you can't multiply by 5 to fix it. On number 3, you can't multiply by 9 to fix it. What could you multiply by to fix it? 45. (4/5) times x minus 10 equals negative 8/9. Again, you use the 9 times the 5 as a 45, and I multiply by 45 on here and on here. And then my 45, 5 goes in here once, 5 goes in here 9 times. 9 times 4 is 36. I don't want to really do 8 times 45 divided by 9. I could if I had a calculator. But I personally am going to say 9 goes in here once, 9 goes in here 5 times, and 8 times 5 is 40. Notice, look, Mom, no fractions. Now you can just solve from there, and it should be. All right, if you look at the back side, yes, there's a back side. But given that we have a lot of time left in class even, I think you'll be able to handle it. Let's just do number 14, because it usually gets a lot of people, and it's the first problem in that section, and I hate for the first problem to be tricky. So let's do 14 together. It says P equals C plus CM. And you're supposed to solve it for C, which means at the end I want C alone. But I can't get C alone until there's only one C. Like one of these terms can have C and the other one can't. If I subtract CM, it's just going to move it to the other side. So that doesn't work. Here's the key to this one. Everybody write this one down. P equals C times parentheses. Does anybody figure out what I'm going to do here so that I'll only have one C? And so this would be, what would go right here? The way you said it is right. I'm dividing by it. But what I mean is, this is called factoring. I'm factoring out a C. Get how there's a C in here and there's a C in here? If there's a C in both of them, I can factor it out to the front. And when I take a C out of both of them, what do I have left? C times what would give me my C? 1. C times what would give me my CM? So now I've got it down to only one C. All right, so I'm going to divide both sides by 1 plus M. Switching back and forth between black and blue. And then these will cancel. As long as C is alone, I'm good. Now, I'm helping you a lot by telling you this, but I need you to understand what I just did, and I still get the feeling a lot of you are like, I don't know what just happened. So I'm going to do another one like it. Y equals R plus RP. How do I get that down to just one R over there? Use the word factor in your answer. Factor out the R. Y equals R times what I put, plus, and now there's only one R, so now I can get rid of the other stuff. Divide by 1 plus P on both sides. Cancels, cancels, R's. Okay, that's a good technique to know. All right. There's enough homework today. 21 questions, but I did do several of them for you, and we have some time left. So I want to have some time for work time, so if you have questions, I'm glad to help you up here. That's all we got for the video.